Hi learners, welcome to the today's topic. Today I am going to discuss about the question bank questions related to the topic clustering methods. Myself Priyanka Gupta, I am working as assistant professor in Department of Computer Science and Engineering Data Science at Institute of Aeronautical Engineering, Hyderabad. So basically I am going to cover all the related questions on the clustering method. I'll discuss about the few questions here in today's class. What is clustering? What is clustering method? Clustering is the process of grouping together some of the objects. Those belongs to the same group. That is going to belongs to the same group. That is having the similarity in common. And with those, that is going to create a group. That is going to create a group. So suppose if there are some points, if there are some classes, yes and no, right? So, that is simple class levels related to some data. If some of the points are there that is related to the yes, that is related to the yes. Some of the points are there that is related to the no here. So here that is going to make a one cluster for yes, and that is going to make a cluster for the no. So what are the points related to the no class level that will go on that particular no cluster? What are the data points that will be related to the yes class level that will go in there? So like this, the cluster will be distributed. So clustering can be considered to the most important unsupervised learning, because we are not giving here in any training set. We have to classify those set what we are having in that all the database, that is working from the all the database. So let's understand this with the example. Suppose if we are having a head of a rental store, and I wish to understand the preferences of the customers while we are having for our business. So we have to know about the each customer, right? Each customer detail. No. So what we can do for that, we have to cluster all the customers. How many cluster types, how many customer types are there, right? So if the customer is, suppose that is purchasing so oftenly, some of the customers, they are not purchasing anything, some of the medium customers are there. So there we can make the 10 groups related to that based on their purchasing habit in this example. So we have to use a strategy for that. We have to make a 10 group. We have to make a 10 groups on the basis of their some of the class levels, so based on the purchasing habit. So the groups that we are going to make on some criteria. So that will be the clustering. That will be the some 10 clusters. So that is in that extent we can understand that. Next question is, what are the requirement of clustering? So if we are going to do the clustering, what are the things we need? What are the main requirement we need? So the main requirement that a clustering algorithm should satisfy, there will be the scalability. Clustering on a sample of a huge data, if we are having the large data, so that can lead to a partial results. So highly scalable clustering algorithm will be using for that. So that is not going to cover all the huge data. So the partial result we can have in the clustering while we are using the clustering method. Second will be the dealing with the different type of attributes, right? If we are having the different type of attributes in that particular that database, so some algorithm is going to design the cluster interval based. However, the application that is going to require for the clustering, that will be the several type of data. That is going to include the binary data, categorical nominal data, ordinal data, a combination of these three data. So we have to understand about what is the data is there, and then we have to apply the clustering. Third will be the discovering the clusters with the arbitrary shape. So some of the clustering algorithm that is going to determine clusters depending on the what I have said. If there will be some points, if there will be the one cluster is there, right? Yes and no example. If I take no, here we can change gender type of. So if male is there and female is there, male is there and female. So female is having here some points. So these are the two clusters. In that, what we have to do while we are doing that clustering, we have to check the what is the distance between them. Then we can make a one cluster. So that will be there will be some technique. There will be the Euclidean method, that will be the Manhattan distance measure. On the basis of that, the distance will be measured for each point of one cluster. So the algorithm that is going to depend on such distance measure, that is tend to discover that having the spiral clusters. So if there will be the some this shape related some clusters, so with the same size and density, but the cluster can be of any type. So like this, we have to check the clustering, what clusters, what maximum points we can take in one cluster. Next is minimal requirement for domain knowledge to determine the input parameters. So we before the clustering we are applying, that have to know about the input parameters. Some clustering methods that is going to need users to input specific parameters for the cluster analysis. So they will have the user specific parameters. The parameter that is in the clustering results, that is going to give the absolutely sensitive data, sensitive inputs. So on the basis of that, the parameter will be difficult to decide and handle that for that data set. When there will be the high dimensional data, there will be the high dimensional data, then that will not work. That is not only for the task users, but also we are going to create the quality of clustering difficult to control. So we have to have the domain knowledge before we are going to apply the clustering. For the we have to understand about the parameters. If they will be the 3-dimensional, 4-dimensional, multi-dimensional, so there will be the problem. So we have to first understand about that. Then that will be the minimum required for applying the clustering method. Next is ability to deal with the noise and outliers and missing data. Most of the real world databases that is having the outliers and missing value and known value, error value, erroneous information. So these are the some clustering methods are there to key on the such data that is going to lead to the clusters of poor quality. So there should not have any noise, missing data, these type of ambiguity, so that will not affect for the cluster, for to make a cluster. Next will be the next requirement is insensitivity to order of input records. Here, some of the clustering algorithm are there. They are sensitive in the order of input records, right? If the records are not matching, if the domain parameters we don't know. So given a set of examples of data objects, that is including the algorithm that can return the different clustering depending on the, in order to representing the input objects. So it is essential to develop some clustering algorithm that is insensitive in order to input. So what are the input and output records are there? So we should have take care of that because that should not have sensitive data. There would, if sensitive data will be there, that will affect the cluster. Next is high dimensionality. A database, we can say data warehouse can including the multiple dimension and attributes, because that is multi-dimensional also in the nature. So some of the algorithm related to clustering that will be managing the low dimensional data that is containing the 1 or 2 or 3 dimension. But more than 3 dimension, that will be the problem. So human eye are best to determine the quality of clustering that for the 3 dimension, right? More than 3 dimension, that will look like a concept hierarchy. So that will be the difficult to work on. It is used to find clusters of data objects in high dimensional space will be complex, especially if that is going to work on the highly skewed data, highly inadequate data. So high dimensionality will not work for clustering. So there should have the up to 3-dimension data. Next point is interpretability and usability. So interpretability, users expect the clustering methods or results to be interpretable, that will be comprehensive in nature, and that they can use. But that is, clustering may not be tied to these interpretations and applications. So it is important to study how an application goal that is going to affect the selection of clustering features and methods. So that on the interpretability and usability, that will be not working on that. Next question is, state the category of clustering method. So the various type of clustering methods are there. Some few are there listed here. Connectivity based clustering, that is hierarchical clustering. Why connectivity? Because some of the blocks that will be connected in nature. Next is centroid-based clustering, that is partitioning cluster. Distribution-based clustering. Next is density-based clustering, that is also called as a model-based clusters. Fuzzy clusterings and constraint-based clustering, that is supervised clustering. So we will take first connectivity-based and hierarchical clustering. Hierarchical clustering, basically it is a method of unsupervised learning, unsupervised clustering, where it is going to begin with a undefined top to bottom hierarchy. So there will be the top to bottom hierarchy. Some of the point will be like this. So that is actually hierarchical clustering. That is a dendrogram. It then going to proceed and going to perform a decomposition of all the data objects. So all the data objects at each point, that will be divided and subdivided at each level. So that will be working on a hierarchy. Hence, that is going to obtain a cluster. So this method basically that follows two approaches, that is based on the direction of progress. First will be the top down, second will be the bottom down flow. So that first will be the decisive approach, second will be the agglomerative approach. Next clustering is centroid-based clustering, that is partitioning method. So centroid-based clustering is considered as one of the most simple clustering method. The intuition behind that centroid-based clustering is that is a cluster is categorized and represented by a central vector, and the data points that are very, very close in proximity and to these vectors. So that is going to assign to that respective clusters. So the centroid, there will be we can say some of the centroid that will be nearest to that. The points will be there. There will be some centroid value, center value. So on the basis of that, each distance that for clustering, the model is going to follow. So there will be the central vector, that will be the vector. On the basis of that vector and other points, the proximity that will be calculated on the behalf of that. So that will come in the partitioning method. Next is in that these groups of clustering method that is do that things in iterative nature, that is going to measure the distance between the clusters and the characteristics of centroid, that is using the various distance metric, that is including the Euclidean, Manhattan and Minkowski. So these are the few methods for that, using for the distance measuring. Owing to its simplicity, while it is very, very simple in nature for implementing and interpreting, this algorithm is having the wide application uses in the area in market segmentation, customer segmentation, text topics retrieval, image segmentation, text mining, etc. So that all the clustering centroid-based applications that will be working on that particular method. Next clustering is density-based clustering, that is model-based methods. So density-based clustering methods that takes the density into consideration. Density will be there instead of distance. So we were using distance for the first and second. but here we are using the density. Clusters will be considered here. So these group of clustering method that so clusters that are considered as a densest region of the data space. So the what is the density? The common will be there. The density what is the dense space is there that will be occupied for that cluster. So which is going to represent, that is going to be separated by region will be there. So region will be the lower object density, and it is going to define by the maximal set of connected points. So basically the density based algorithm that can get us clusters with the arbitrary shape. So they the shape can have the arbitrary in nature. So clusters without any limitation in cluster sizes and will be there. So they can contain the homogeneity by assuring the same level of density within it. So that can have the noise and outlier for that. So density based algorithm, that will be risky to use. Next is distribution based algorithm clustering. Some clustering algorithm that is going to take a totally different metric, that is probability. So first in the two clustering we have taken the distance, in third we have taken the centroid and density, and now we are using the probability. So probability in that the grouping of data points will be in the nature of likelihood that is going to belong to the same probability distribution. So that can have the Gaussian binomial in the data. So that will work on the data distribution. So its advantage is there over the proximity and centroid-based centering method, clustering method what we have used. The term of flexibility, that will be flexible in nature and correct that will be correct in nature, and the shape will be not arbitrary. That will be the normal shape. Next, if clustering is fuzzy clustering. Fuzzy clustering is revolving around the assigning data points. The assigning data points that will be mutually exclusive in nature. For the clustering, that means a data points always that is going to reside uniquely inside a cluster, and it cannot be more than one cluster. So in fuzzy clustering method, there will have a membership. So the data points that are proximate to the center of a cluster, that will belong to the same cluster. So that if that will be the higher degree for that points, so that will be the age of that cluster. The possibility and will be there for one element for the given cluster. So that will be work on the membership coefficients. That will be in between 0 to 1, like 0.1, 0.2, 0.3, like till there 0.9, 1. So that 0.2 to 0.9 the values will be there. 0.1 to 0.9 the values will be there for membership, and on the basis of membership function, all the possibility of the cluster is elements is belonging to that particular customer, that will work within the proximity. The fuzzy clustering that can be used with the data sets with the variable can be high level of overlap, and for the image segmentation. So these are the few applications to use the fuzzy clustering. Next clustering is constraint-based clustering, that is supervised clustering. The clustering process in general is based on the approach that the data can be divided into the unknown groups. So the constraint can be there, that the desired property of the clustering result, we can say if we are expecting some of the cluster, some of the group that can be formed. So this can be in terms of fixed number of clusters or cluster size, or we can say some of the important dimensions and class levels variables. So that is going to require in the clustering process. So usually the tree-like structure in that decision tree, random forest, gradient boosting. So these are made up of the constraint-based clustering. So this was all about clustering. Next question is, what do you mean by hierarchical clustering? So hierarchical clustering is also known as a hierarchical cluster analysis. That is an algorithm that is going to group similar objects into into one group, that is called as a cluster. The endpoint of is a set of cluster where each cluster is going to distinct from each other cluster. The object of the each cluster is broadly similar to the each other. They will be similar to each other. So it is going to do the subsequent steps, that is identify the two clusters which can be closest together, then merge the two maximum comparable clusters. Again and again we have to do these are the things in hierarchical clustering. In hierarchical clustering, the aim is to produce the hierarchical series of nested clusters. So a diagram will be called as a dendrogram. Dendrogram will looks like this. If it is starting from here, it is some of the points are here, some of the points are here. That will work here. So again, that is some points. There are points. There is other points. So like this, that will look like a dendrogram. That is a tree-like structure. That is that statistics of sequences of merging and splitting. So graphically, it is going to represent the hierarchy, and it is the inverted tree. That is called as an inverted tree that will work from top to bottom, and that is going to describe the factors that is going to merge in the bottom view. Clusters are broken into the top-down view. So these are the two view. If merging will be there, so we will see the bottom up view. If clusters are breaking at some point, so that will be the top-down view of that. Next is, what do you mean by agglomerative clustering? So agglomerative clustering is a type of hierarchical clustering. This is a sub part of hierarchical clustering. It is an unsupervised technique that is going to divide the population into several clusters such that the data points will be in the same cluster, are more similar, and data points will be different clusters will be dissimilar. On the basis of similarity and dissimilarity, it will work on. Next question is, what do you mean by divisive tree clustering? The divisive clustering algorithm is a top-down clustering approach that initially in that all the point will be there in the data set that belongs to the one cluster, and then the splitting will be performed recursively as it is moves down to the hierarchy in nature. So that will be the divisive clustering of those data sets. What is outlier detection? Discuss about outlier detection. Outlier detection means finding out the data objects whose properties and behavior are different from the rest of the objects in the cluster of the data sets. So if some clusters are there and suppose one point is there that is not belongs to any points, that if suppose it is here and that will not belongs to that particular cluster, that will be the outlier. So outlier detection is the process of finding the outlier from the normal objects. It is essential while we are going to perform the outlier detection during the data pre-processing. The outliers highly affect the performance of the classification and clustering models. So the outliers, these type of outliers we have to remove from that particular cluster. If we are going to make a cluster like this, and that is here, some of the points they are similar, and that is very, very far, so we have to remove those outliers or noises. So outlier can be of two types, three types basically: the global or point use outliers, collective outliers, and contextual outliers. First is global outlier. They are known as a point outlier actually. These are the simplest form of outlier. So some points will be there that will be not related to the one cluster. If in a given data set, a data point strongly divides from all the rest of the data points, that will be known as a global outlier. So that is at any point the data points is not related to the other data points. For example, in intrusion detection system, if a large number of packages will be broadcasting at a very short span of time, so this can lead to the global outlier. So we can say that particular system has been potentially hacked. Second is collective outlier. So as we can say, as name suggests, if in a given data set some of the data points that deviates significantly from the rest of the data set, that may be a collective outlier. For example, in same intrusion detection system, a denial of service package from one computer to another computer, that may be considered as a normal behavior. However, if that will happen with the several computers at a one time, same time, but if that will not working at a one time, that will be abnormal behavior, and that whole will be called as a collective outlier. Next is contextual outlier. So that will also called as a conditional outlier. So here, if if a given data set is there, a data object that deviates significantly from the other data points, but that will be based on the some context or some condition will be there. So the outlier contextual outlier analysis, that is providing the flexibility for user, where one user can examine outliers in the different contexts, which can be highly desirable for the many application, because if the point, the outlier is related to some we can say some clusters, if the user they know that that is related to that cluster, so the contextual outlier detection will be applied. So in that, the attribute of the data points are decided on the basis of both contextual as well as the behavior attribute. For example, a temperature, it is going to read 40 degrees Celsius, that is may behave as an outlier, because in the context of winter season is there, the temperatures cannot be at 40 degrees Celsius. That will be less than 15 or 20. So behave like a normal data points in the context of summer season. So that data points the user can they can use in the form of summer season. So they can add the data points in the summer season cluster. So that was all about the clustering questions, what was related to the question bank. Thank you for watching.
Like, share and subscribe. Hit the bell icon for more updates.